Okay, we're going to talk today about adding fractions. This is just getting us started for our adding and subtracting of rational expressions. And before we do that, let's just discuss why is it that we need a common denominator to add? Well, if I were to think about it in terms of pizza, right? Here's one pizza. It's cut in half. Here's another pizza. Nobody cuts pizza like this, but imagine you cut it into 3 pieces. So if I wanted to add 1/2 and 1/3, the problem is they're not the same size. So the reason why we find a common denominator is because we can actually keep cutting the pizza up, can't we? What's the common denominator between a half and a 1/6 or and a 1/3? I just said it. Oops. It's a what? It's a 6. Okay. I got ahead of myself. So I keep cutting the pizza. Now I've cut this pizza into how many slices total? 6. So that means each slice is 1/6. If I have 1/2, how many 6 is equal to 1/2? 3/6. And so I multiplied essentially by 3/3. I multiplied by 1 whole, right? So I didn't change the fraction. I mean, I changed it to a different kind of fraction, but I didn't change the value of the fraction. It's equivalent. So 1/2 is equal to 1, 2, 3, 6. Over here, I have thirds, right? So if I have one of those thirds, how many 6? Well, if I cut each slice in half, essentially I'm multiplying by 2/2 because 2 times 3 gives me 6. And 2 times 1 gives me 2. So 2 of the 6 is equal to 1/3. These are what we call equivalent fractions. So now when we add, we say, well, I have 3/6 plus 2/6, and that gives me 5/6 total. 1, 2, 3, 4, 5, 5, 6. So the reason why we have to have common denominators is because otherwise we can't add them together because they're not the same size. All right. If I look at that 1/2 section and I look at 1/3, what would I add together? You know. Anyway, I have a lot more videos on fraction operations. So if you're still struggling with fractions, be sure to let me know and we can get you those videos. Okay, let's go ahead and talk about how we are going to add rational expressions. We just had a little typo here because it said radical expressions, but in fact, these are rational. Radical would have been this sign here, radical sign. We're using rational, which are a fraction. Just a little typo. Okay, adding and subtracting when denominators are the same. To add or subtract rational expressions with a common denominator, you're just going to add the numerators and use that common denominator. The result should be simplified whenever possible. That means you're going to reduce your fractions. Okay, simplified means reduce. Here are some examples. So if we want to add 6/5 and 2/5, we have a common denominator. So how many fifths would we have? 8/5. And is that fraction fully reduced? Yeah, nothing goes into 8 and 5 evenly, so we can't reduce it anymore. Notice that you could also, this is what we call an improper fraction. You could write it as 1 and 3/5 because 5 goes into 8 one whole time, leaving 3 left over, 3/5 left over. So that's equivalent. We call this one a mixed number. And this one an improper fraction. You can use either one. I will say mathematically in algebra, it's actually a little more convenient to use an improper fraction, but a mixed number could be more friendly when it comes to a word problem. If you're trying to say you have 8/5 of a pizza, it's kind of awkward to say, but you might say you have 1 and 3/5, right? Even though nobody cuts pizzas into 5 slices, really. It's unheard of. Okay. Here we have a common denominator. So I don't have to get a common denominator. I'm just simply going to add the numerators. So I get 12 over x plus 2. We keep the denominator the same, correct? Now, could I reduce this 12 and 2? And you should say no. Why? Because there's the x involved, right? So there's nothing that can be factored about the x plus 2. And therefore, we can't really reduce anything here because we were talking about how you cannot reduce over addition. All right, here we're subtracting, so we have 23 minus 20, and our common denominator is 21. So what do we get here? 3 over 21. Can we reduce 3 over 21? It's 1/7. How did you get 1/7? Yeah, exactly right. They're both divisible by 3. So we could divide, if we can divide the numerator and the denominator by the same number, we call that number the GCF, the greatest common factor. So 3 is the biggest number that goes into 3 and 21, and that's how we reduce that. Now here, this one gets a little bit tricky because when you're going to subtract, you want to subtract this whole entire numerator. So you would have 6x minus 7 minus 4x minus 3. Do you see how I have to distribute that negative sign in order to subtract the numerator? That's going to be a key piece. And then in the denominator, we're just going to keep the x minus 5. All right, so let's go ahead and combine our like terms. In the numerator, we have 6x minus 4x gives us 2x. And negative 7 minus 3 is what? Yes, negative 10. Great. Over x minus 5. Now, we want to look at that and say, can I reduce it? In order to reduce it, what should we do to the numerator? And I hope you said factor, right? Factor. Okay, so can the numerator factor? I'm just going to carry it down here. So we're going to factor out a 2, and we get x minus 5 over x minus 5. Can anything reduce? These cancel. We get 2. And then we should say that x cannot equal what number? 5. So that's retaining, that's basically saying, okay, even though those things disappeared, those two factors were exactly the same, so I could cancel them, I still do have a restriction on my domain. I can't use 5. So even though my answer is simplified to 2, I still am going to put that restriction on the domain. Okay, any questions about doing this with common denominators already?